Picture this, a ship so massive that 2 football fields could fit on its deck. Inside it, thousands of containers, millions of tons of cargo, cars, electronics, food, medicine, everything that eventually shows up at your doorstep. And right now, this ship is sitting in the open ocean, water in every direction, no coastline, no land, no lights anywhere in sight. Now imagine a storm rolling in. The sky turns dark, the waves start picking up. The captain, standing on the bridge, gives the order, drop the anchor, hold the ship steady, and the answer comes back. Sir, the anchor won't work here. Wait, won't work? The same anchor that's been humanity's most trusted tool for stopping a ship for thousands of years, the one that shows up in every cartoon, every movie, every childhood story as the symbol of the ship has stopped. How does it suddenly become completely useless on one of the biggest ships ever built? This isn't a malfunction, it's not some flaw in the design either. It's a simple but genuinely surprising fact that plays out every single day, on nearly every cargo ship, in every ocean around the world. And until you know the real reason behind it, it looks like a failure of engineering. But the truth is the exact opposite. Humans found an answer to this problem that doesn't rely on chains and metal at all. It runs on GPS, satellites, and computers. And trust me, the answer is a lot less simple than it sounds. There's physics in it, engineering in it, and a whole shift in thinking that changed the entire shipping industry. In this video, we're going to understand 3 things. First, how an anchor actually works, and why it's considered so reliable in the first place. Second, why the depth of the ocean makes an anchor completely useless. And third, when the anchor doesn't work, how the biggest ships in the world hold their position anyway, without any chain, without any metal touching the seabed at all. If you've ever wondered how these enormous ships stay under control out in the open ocean with no land to rely on, by the end of this video, you'll have the full answer. Let's start with the basics. What does an anchor actually do? Hearing how an anchor works, it sounds pretty simple. Drop something heavy into the water, and the ship stops. But the reality is a bit more interesting than that, and it's also where most people get it wrong. The anchor itself isn't heavy enough to hold a ship in place on its own. The real work is done by the chain, a long, heavy steel chain connecting the anchor to the ship. When the anchor reaches the seabed, its flukes, those 2 pointed, arm-like parts, dig into the ground, much like a hook. But that hook alone isn't what creates the holding power. The real magic is in the weight of the chain. The chain is so heavy that when it lies across the seabed, most of it doesn't pull straight upward. It lies flat along the bottom, like a wave resting on the ground. This horizontal pull is what actually helps hold the ship steady, because if the chain pulled straight up, the anchor would simply rip out of the ground and the entire system would fail. That's exactly why experienced sailors always say, it's the chain that does the real work, not the metal. This isn't a new idea at all. Humans have been working on this same principle for thousands of years. In ancient times, sailors would tie large rocks or chunks of metal to ropes and drop them into the water. Over time, the design improved. Flukes were added for better grip in the seabed, and eventually, the stockless anchor design came along, which is still used on most large ships today because it folds neatly into the hull without taking up extra space. The simplest way to understand this is to think of your car's handbrake. A handbrake stops a car that's already slow or already parked. A small amount of effort brings the whole vehicle under control. But if you pull the handbrake at 100 kilometers per hour on a highway, it won't work. It'll actually cause damage, and the car will spin out of control. An anchor works exactly the same way. It's built for shallow, controlled conditions, near a port or in a bay, where the water isn't too deep and the seabed isn't too far away. So the question becomes, what happens when the water isn't limited anymore, when the depth stretches down thousands of meters? Can the anchor still somehow work, just taking longer? Or does it become completely useless? That's the real problem at the heart of this whole video. Let's break it down with the numbers. This is where the numbers really matter, because they tell the whole story on their own. The average depth of the world's oceans is roughly 3,700 to 4,000 meters. That's not just some random figure. It means that if you're standing on a ship in a random spot in the open ocean with no coastline nearby, the chain would need to reach nearly 4 kilometers down just to touch the seabed. Now, let's look at how much chain a large cargo ship actually carries. By international standard, big ocean-going ships carry roughly 12 shackles of chain per anchor, and each shackle measures about 27.5 meters. That adds up to a total chain length of roughly 300 to 330 meters. This is thick, heavy steel chain, where a single link alone can weigh several kilograms. Let's hear those numbers again, because this is really the heart of the whole video. The chain is 300 meters long. The average ocean depth is over 3,700 meters. That means the chain is less than 10% of the length it would actually need to reach the bottom. Here's a way to picture it. Imagine trying to lower a 30-meter rope into a well that's 400 meters deep. The rope will never reach the bottom. It'll just hang there, in mid-air. That's exactly what's happening here, just on a massive scale, with much higher stakes. And it's not just a question of whether it reaches or not. If you tried to force a chain into a depth it was never meant to cover, the entire chain would just hang straight down, the anchor would never touch the seabed, and the sheer weight of the chain itself would create a dangerous load on the ship's structure. The chain could snap under its own weight or damage the anchor equipment on the ship. That's why a place like the Mariana Trench, the deepest point in the world's oceans, roughly 11,000 meters deep, deep enough to swallow Mount Everest and still leave its peak underwater, isn't even a place where the question of anchoring comes up. No commercial ship could carry a chain long enough or heavy enough for that kind of depth. Here's a quick "did you know" fact. Whenever you see a cargo ship anchored near a port, it's always in shallow coastal water, never out in the middle of the open ocean. That's not a coincidence. It's a hard physical limitation that every ship, no matter how big or advanced, has to follow. And there's another thing worth understanding. The length of the chain isn't the only problem. Even if you somehow built a long enough chain, it would be so heavy that it simply wouldn't fit in the ship's chain locker, and pulling it back up would require far more power than any normal equipment could provide. This isn't just an engineering challenge, it's close to a physical impossibility, like asking a small construction crane to lift and move the entire Burj Khalifa. So here's the simple truth to take away. An anchor is only designed for shallow, coastal waters. Out in the open ocean, where land is nowhere in sight, this tool is completely useless. That's not a flaw, it's simply the limit of its design, and every engineer, every captain knows it. And it's around this exact limit that the entire maritime industry has rebuilt the way it operates. It's also worth pointing out just how counterintuitive this feels. We tend to assume that bigger ships come with bigger, stronger versions of everything, bigger engines, bigger anchors, bigger chains. And in most cases that's true. But size doesn't solve this particular problem, because the issue was never about strength, it was always about depth. No matter how large or powerful a ship gets, it still can't stretch a 300-meter chain across a 4-kilometer gap. So then the question is, if the anchor doesn't work, what happens when a storm hits, or when a ship needs to hold its position for some other reason? That's exactly what we're covering next, and this is where things get genuinely interesting. The modern shipping industry answered this problem with technology, not chains. The first and most advanced method is called a dynamic positioning system, or DP for short. The simplest way to picture it: imagine the ship has an invisible GPS-based lock on its position. The ship is fitted with multiple thrusters, small propellers that can push in different directions, some even mounted on the sides of the ship, not just front and back. An onboard computer constantly checks the ship's exact position using GPS and satellite signals every single second. If waves or wind push the ship even slightly off course, the computer instantly adjusts the thrusters to bring it right back, with zero need for manual human control. This system is so precise that drilling ships and research vessels, which need to stay in one exact spot in the middle of the ocean for weeks or even months, for things like oil exploration or scientific research, run entirely on DP systems, with no anchor at all. Ships that build offshore wind farms use the same technology too, since they also need to stay perfectly steady at one fixed point. The second method is simple drifting with engine control. Not every situation calls for something as advanced as a full DP system. Cargo ships that only need to hold position for a short while will apply a small amount of engine power to balance against the current and the wind. It's not fully automatic, but the captain and crew keep the ship within a general area manually using GPS tracking, adjusting engine power whenever it's needed. The third concept is the sea anchor, also called a drogue. Despite having anchor in the name, this isn't an anchor at all. Its job is completely different. It's essentially a large, parachute-like device that opens up underwater. It never touches the seabed. Instead, it uses water resistance to control the ship's speed and drift. This is mostly used on smaller vessels or lifeboats during storms to keep the bow of the ship facing the waves so it doesn't get hit side on and capsize. And behind all of this, the real game changer is modern satellite navigation and tracking. In the past, ships relied purely on visual landmarks, or the stars, to figure out their position. If the sky clouded over at night, the captain was left guessing. Today, GPS is accurate enough that a ship can know its exact position within a few meters, in real time, whether it's in the middle of the Pacific or the Atlantic, day or night, in any weather. Here's an interesting fact. Some advanced DP systems are precise enough that even during storms, a ship can hold its position within less than a meter for hours at a time, with no chain at all, purely through computers and thrusters. This is the kind of technology that used to sound like science fiction, and now it's completely routine. And the beauty of this technology is that it even learns from its own failures. If one thruster stops working, the system automatically adjusts the power on the remaining thrusters to keep the position steady, much like how the human body automatically rebalances if someone is limping on one leg. That's exactly why DP systems are considered the most reliable method for critical operations, like transferring cargo near offshore oil rigs. It's worth remembering that none of this happened overnight. Ships have been slowly moving toward this kind of automated control for decades. As computers got smaller, satellites got more accurate, and thrusters got more powerful. What used to require a whole team of sailors constantly adjusting engines by hand is now handled by a system that reacts in a fraction of a second, far faster than any human crew ever could. So these four methods, DP systems, engine-controlled drifting, sea anchors, and satellite navigation, together do the job that used to belong entirely to the anchor. But here's the question, why does all of this even matter so much? Its impact isn't limited to one ship. It affects global trade as a whole. Let's look at that next. The technology we've been discussing isn't just a technical solution. It's what keeps global trade running, and it protects the safety of thousands of people at the same time. Think about it. If a ship out in the open ocean faces a storm with no way to hold its position, the outcome isn't just a delay. It could mean a collision, damaged cargo, or a direct threat to the crew's lives. When a ship can hold its position using a DP system or controlled drifting, it can safely ride out the storm without taking on any real risk and without any panic on board. This is exactly why, outside busy ports, when a large number of ships are waiting for their turn, something known as port congestion, they also don't drop anchor if the water is deep. They hold their position using engine power or DP systems, staying within a fixed area through GPS tracking, so that the moment their turn comes, they can move straight into port without confusion or delay. This system is essential to the global supply chain. In today's world, where even a small delay can cost millions of dollars, and where a single ship's delay can ripple through an entire supply chain, a factory not getting its raw materials on time, or a store shelf sitting empty, the ability of ships to efficiently hold their position, whether during a storm or while waiting outside a port, keeps the entire trade cycle running smoothly. And this isn't a small-scale issue either. Thousands of cargo ships are moving across the world's oceans at any given moment, carrying everything from raw materials to finished products, and a huge share of them will, at some point, need to hold a fixed position without ever touching bottom. Multiply that across the entire global fleet, and you start to see just how much modern trade actually depends on this quiet, invisible technology. Picture a world without this technology. Every ship facing a storm or congestion would only have two options: drift around dangerously or travel far away to find some shallow area to anchor in, wasting weeks in the process. Global trade today, which runs on just-in-time delivery, where factories, stores and hospitals expect their goods to arrive at an exact time, simply cannot afford that kind of delay. That's exactly why the modern shipping industry avoids deep-water anchoring altogether. It's not just expensive, since reaching greater depths would require far heavier, far more expensive chain that might never even get used, and the ship's entire structure would have to be built to carry that extra weight. It's also simply unnecessary now that technology offers a better, safer, and more reliable solution. So here's what becomes clear. This was never just an engineering choice. It was an entire shift in mindset, moving away from chains and metal toward computers and satellites. And this shift happened quietly, almost unnoticed. But today, it's become the backbone of the entire maritime industry. So let's recap everything one more time. The anchor is still just as important today as it was centuries ago, but only in shallow coastal waters. There, it remains the simplest and most reliable way to stop a ship, and there's no need to replace this technology at all. But the moment a ship heads out into the open ocean, where depths stretch down thousands of meters, the anchor hits its limit. The chain simply isn't long enough, and reaching the seabed becomes physically impossible. This isn't a minor shortcoming, it's a fundamental limit. This is exactly where human engineering found a new answer: dynamic positioning systems, controlled drifting, sea anchors, and satellite navigation. Together, they made possible what used to be imagined only through a chain and a piece of metal. Today's ships hold their position not because of anything heavy, but through invisible signals and precise calculations. So the next time you see a picture or a video of a massive cargo ship out in the open ocean, you'll know its control doesn't come from some heavy anchor, but from the computers, satellites, and precision engineering working inside it. Just think about it. Humans learned to control land, then learned to fly through the air, and now we've even brought the deepest parts of the ocean under our control, without ever touching a single thing, just through signals and calculations. If you found this video interesting and you want to keep discovering these kinds of surprising engineering secrets that surround us every day but go completely unnoticed, make sure to subscribe to the channel and don't forget to like this video so more videos like this one reach you. In the next video, we're going to talk about something that might be even more surprising: how the biggest ships in the world manage to carry enough fuel for weeks-long journeys across the ocean with no gas station in sight. Don't miss that one. See you in the next video. Until then, take care.